Welcome to the CAE Project 2 final presentation, where we will be demonstrating our Tampa International Airport simulation. Before we start our presentation, we would like to make a couple of acknowledgements, the first being Tom McCann from CAE, who kept close correspondence with us and helped us through this process, as well as Dr. Christensen, who also kept a close eye on us and helped us every step of the way. Third being the CAE developers, who helped us with assets and also how to create some of the things you'll see in a moment. And then fourth, FlightAware, who were a really close API that helped us communicate with them and make sure that we are getting what we needed for our project. Now moving on to the agenda, here are the things we're going to be covering, such as the background for our project, our problem and requirements, our solution, which is going to be our demonstration video, our design, implementation, and the summary of our project, as well as the future work that we may be doing with CAE. So let's start with our background. To create the 3D simulation that we made for the Tampa International Airport, we had to think of airports in general, which help airplanes, which are a quick and easy form of travel, but we realized that our project centers around air traffic and the use of air traffic, which makes quicker taxiing for airplanes to get from the runway back to the terminals, allows for less cluttered runways, as well as airplanes to arrive and leave on time. During our research, we found that there were many different methods to maintain air traffic, a lot using computers. We realized that CAE, the simulation company that contracted us, wanted to use this information for their own simulations that they create for clients as well for government contracts. This brings us to our guiding problem for our entire project, which is, can we create a real-time simulation of airplanes at the Tampa International Airport? We'll be looking more in depth at this question in the following slides and the rest of the presentation. This brings us to our requirements, first of which being creating a model of the Tampa International Airport, or TPA. This model can be of low fidelity meaning that it doesn't need to have windows or the bells and whistles that show that it is very specific, but specific enough that shows that this model is, of course, the Tampa International Airport. Our second requirement is that we need to annotate this specific Tampa International Airport model, which means that it must be detailed enough to show and distinguish the gates and terminals, meaning that the gates must be labeled as well as the terminals must be labeled accurate to a diagram. Our third requirement is that we have several aircrafts that inhabit this 3D simulation and 3D environment. There must be at least 2 different aircraft models that will populate this environment. And our fourth requirement is that we have different viewing perspectives of the airport, meaning that in Unity, the game engine that we will be using, that there are 5 different cameras that are angling at the Tampa International Airport, so that we can view the simulation from several different perspectives. Now moving on to our other requirements, number 5 being that our simulation must run off the real-time information gathered from the Tampa International Airport. This is using an API of some sort to trigger the airplane animations that will be created in Unity. Finally, we have our 6th requirement, which is a current representation of the weather at the Tampa International Airport. This is the use of an API to gather information on the current weather condition at the Tampa International Airport. This must be displayed in one of 3 ways, based on the weather, each condition being listed below, first being cloudy, second being rainy, and third being sunny. These will be displayed somewhere in the simulation. Now we come to the fun part, which is our solution/demonstration. We will be showing you in this video the requirements being met in our simulation that we created. Please follow along in this fun video. Welcome to the CAE Group 2 Senior Project Demo. In this video, we'll be demonstrating our 6 requirements, which are having a low-fidelity 3D model of the Tampa International Airport, having the airport model include annotated gates and terminals, having at least 4 3D models of aircrafts used in animation, having a minimum of 5 camera angles for the airport simulation, having the OpenSky API trigger animations of airport traffic, and having an accurate indication of the current weather at the TPA. We will do this by showing you our 3D models, our simulation, and then our simulation intercut with real-time footage of the TPA. We'll start with our 3D model of the Tampa International Airport. So as you can see, this is a reference that we used to get our 3D model of the Tampa International Airport. We went into Google Earth and then found the entire tarmac and 3D model of the Tampa International Airport, and then as you can see on the left, we created our own 3D model of the Tampa International Airport and then labeled it and annotated it so that it would meet our requirements. Here's some more reference photos of the tarmac and the terminals that we used. So now that we showed you our references, let's show you our 3D model and 3D environment. So what we have here is the tarmac and the 3D model of the Tampa International Airport together in our environment in the simulation. On the left you can see the reference photo that we used for the tarmac as well as the Tampa International Airport, and it is annotated so that you can tell what each building is as well as what each terminal is. Now here's a closer look at our 3D model. It's annotated with all the specific information that meets our second requirement. Here we have the main terminal, the remote baggage claim, Terminal A and all of its gates, Terminal C and all of its gates, Terminal E and all of its gates, and finally Terminal F and all of its gates. So as we move on, we're going to demonstrate our next requirement, which is having a minimum of 4 airplanes. As you can see here, we have 5. Each one is based off of a different model. This is a 737 airplane, plain. We wanted to make sure that we had a standard model. Then we have the Canada Air 737 airplane. This is one of the many airlines that frequent the Tampa International Airport. Moving on, we have the Alaskan Airlines plane, which is also a 737 airplane. We have our last 2 airplanes, which are both A320s. The first one is blank so that we have a standard model, and then our second one is the Southwest Airlines model, which we will see in a later simulation later on in this video. So let's get back to our 3D simulation of the Tampa International Airport so that we can show you it in action and our next requirement, which is having a minimum of 5 camera angles. On the lower left hand side you will see the camera numbers, and in the upper right hand side you will see another one of our requirements, which is having an accurate current weather indication at the Tampa International Airport. As you can see, the weather indication has 3 modes: cloudy, rainy, and sunny. Now for our last requirement, we took a trip to the Tampa International Airport itself. We got some footage of the flight schedule and then compared that to our API and found some planes that were on both of them. We found a plane arriving at 11:05 and ran both that footage against our simulation to see how they stacked up. Here's the results. As you can see, the plane has landed and now it is taxiing into the terminal. This Southwest airplane needs to make its way to Terminal A because that's where all the other Southwest airplanes go. Now it is slowing down so it can dock into its gate. Now let's move on to a departing example. Another Southwest airplane is departing from Terminal A at 11:11. So we found that it matches our API, so we're going to run that simulation side by side just like the last one. Right now both our simulation and the airplane are taxiing to the runway. They both turn the corner of the runway and then they're ready to take off. And with that, we complete our demonstration. Thank you so much for watching, and a special thank you to Tom McCann for helping coordinate with us from CAE. Now wasn't that just absolutely delightful? So now that we've shown you our demonstration, let's talk about how we built it. The first thing we need to do is get a really reliable API. We looked around for a lot of different APIs, but the one that we found that was the most cooperative with us in terms of customer service, as well as had exactly what we needed, was FlightAware. We were very lucky to find them, and they were very helpful with us to make sure that we got what we needed. This gave us the departure and arrival times of the flights, as well as the weather condition, which put all of the API information that we needed in one convenient place. Furthermore, we had to make sure that our 3D model was accurate, So we took those reference photos that you saw in the demo and we made sure that we set them against our 3D modeling software and 3D modeled them to a T. Then we took those 3D models and put them in Unity to make sure that they matched up and they were to scale to our 3D model references. From there, we had to get more specific with our 3D modeling and our animation in Unity. So what we had to do was create an annotated version of our TPA model, as well as take several different plane models that we could then edit. The ones that we found were the 737 model and the A320 model. These are models of airplanes that we see constantly at the Tampa International Airport, as well as are on record to visiting the Tampa International Airport often. Then we use those to create the Alaskan Airlines, the Canada Airlines, and the Southwest Airlines models that were seen in the video. Moreover, we had to make sure that these planes were good for animation. So in Unity, we used those planes to create animations that taxied to and from the terminals and specific gates, and then landed and departed from the tarmac. From there, we had to apply the design that we just stated into an implementation using some of the methods that we were thinking at the time. So since we had this connection with FlightAware, we used several different ways to get it into Unity, the first being Python script. We had to take the API queries that we were getting back and then parse them in Python. Then by using that parse, we can send it into Unity and have that read from a file. Then we had to adjust our 3D models. As we said before, we had the 737 and the A20 models, so we edited them in both Autodesk Inventor and 3D Builder, and we created the Tampa International Airport model from scratch using Autodesk Inventor and then 3D Builder to annotate it. Then we had to sew it all together, the API and the models, using Unity. So what we did was create animations in Unity using Unity's own tool. It was simple to use, but there were some drawbacks because we weren't very experienced with Unity. But luckily, we had plenty of time and effort to put into creating some very good animations. So we could run this based on the arrival times that were given by the API and then use the 3D models that we made to create these animations. This brings us to the summary of our entire design process. The main things being the different components that we pulled together to solve our problem. On the left, you can see the reference photo that we used, while on the right, you can see our final product, which is our simulation of the Tampa International Airport, the aircraft that are taxiing into it as well as staying at their terminals and gates, and the annotated model of the Tampa International Airport. Overall, we feel very confident in the fact that we addressed and solved the problem that we were given, which was, can we make a real-time simulation of the airplanes traveling in and out of the Tampa International Airport? We feel confident that we can say yes we can. Finally, there is one assumption that we wanted to address, which is the API usage and how it might cause slight problems. To cut down on cost, because queries cost money, we decided to query every 15 minutes. This creates a small issue that we need to address. The main one being that if the flight schedule changes within 15 minutes, we cannot correct for this. If a plane lands within those 15 minutes, but it's delayed, we will see that the plane is landing and it will stay there. There's not much we can do about that except for querying every couple seconds. Moreover, we find that there's a big assumption that we made, which we feel is fairly accurate. And the assumption being that since we are querying every 15 minutes, an aircraft shouldn't take off and land within those 15 minutes. We feel like this is a just claim considering most plane rides don't only take 15 minutes. And as you can see in the photos, there are two flight schedules, one directly from the Tampa International Airport and the other from our query. As you can see, our query has less information than the Tampa International Airport, but that is because these are the major flights coming in and out, not the personal small flights that the Tampa International Airport sees on its smaller runways. This brings us to our future work with CAE. Tom McCann from CAE hopes that we can take our project and display it in their lobby of their Tampa division of CAE. Tom wants to use his developers, whom we've had contact with, to make this an even better simulation by bumping up the textures and making it more realistic with the animations. With that, we'd like to thank you for listening to our presentation, and we hope that you enjoyed it.